Can wait a minute, a few seconds more. Okay, so welcome to Polycon UK, everyone, again. Today, our guest is Hafer from NYU, and she's going to talk about non-monotonic disclosure in policy advice, which is joint work with Denisenko and Dimitri Landa. We think Anna's going to join us at some point. But if there is nobody else joining us, maybe you can just unmute yourselves and ask Kathy a question if you do have. So it's just easier than asking somebody to look at the chat or asking even Kathy to look at the chat. So that's fine. Just a reminder that in a couple of weeks, 1st of December, we have Sergio Galletta from ETH Zurich, who's going to talk about ballot bot. AI chatbots lower voter information barriers. And I'm going to pass the floor to Kathy. Thank you.
Thank you. Thank you very much for inviting me and giving me the opportunity to try to sell you on this paper today. Anna and Dimitri, my co-authors, Anna Denisenko, who's currently at the Harris School at the University of Chicago, and Dimitri Landa, my colleague here at NYU, are co-authors on this paper, and I think they're going to be joining us at some point. I hope so, because I have to awkwardly apologize now for exiting the Q&A a little bit early. I have to teach class right at the time we would end in a different building on campus. So I'm going to have to run out about 5 minutes before our scheduled end. But I believe definitely Anna and probably Dimitri will be here by then. So the quality of answers will weekly improve when I exit. So our motivation for this project comes from our interest in bureaucratic agencies giving expert policy advice to elected officials. I'm going to go ahead and use the terminology that would be familiar in the US and hope that you can bridge that gap with me. So you have various, usually executive agencies, but not necessarily, that are repositories of expertise, and they may be called upon to provide information or even explicit policy advice to elected office holders. So in contrast to the existing political economy literature on this topic, which is substantial, we want to think about verifiable information rather than cheap talk. So the agency is going to provide advice or information to the policymaker that's going to necessarily be true, right? To just put this in stark terms. So, one might think that they're sort of forced to only report things which are true because there are norms or rules, or an institution that's fairly strong in detecting, tracking down and disincentivizing lying. Or it might be because the messaging itself is in terms of hard evidence, right? So they are sometimes submitting essentially scientific reports. And another way in which we want to part ways with the existing literature is we want to think about situations in which bureaucrats the advisors have non-monotonic preferences in policy actions. So we want to think about a situation in which the bureaucrat has an ideal point in the spatial model. Now, of course, that's very standard in the applied literature on bureaucratic agencies giving advice to policymakers, right? We live in the spatial model quite a bit. But when you think about disclosure games, which of course is the world we enter when we start thinking about verifiable information, in the literature on disclosure games, it's the case in the canonical papers on this and on many applications that have come later, that the informed agent, the sender, would always prefer a higher action on the part of the receiver, or always prefer a lower action, but their preferences are monotonic in the action of the receiver. And when we think about, policy in the spatial model, we would expect that the bureaucrat would have some kind of interior ideal point, that they would want to persuade the bureaucrat to take a higher action for some states of the world and a lower action for others, depending on where their ideal point is located. So we want to think about ideal points in the interior. Okay. So I've gotten a little ahead of my own slides, which I tend to do. Sorry about that. So let me just preview a few results so we know where we're going. So when ex-ante preferences of the sender and the receiver are sufficiently co-aligned, they have enough common interest, we would expect. Can I close this? It's actually blocking my own view of my slides. Just a little. Hang on a second. Sorry. There we go. So when the ex-ante preferences of the sender and the receiver are sufficiently co-aligned, disclosure may be only partial, which is contrary to the standard unraveling results that one sees in the disclosure literature. So, and we get this without any uncertainty about whether or not the sender is informed of the state or how much information, how precise their information is. This is disrupting the unraveling result for entirely different reasons. So that's number one result that I want to preview. Number two result that I want to preview is that for sufficient co-alignment of preferences, when there's enough commonality in the interests of the sender and the receiver, at least from an ex-ante standpoint, there may be multiple equilibria, multiple sequential equilibria. And unfortunately, those multiple sequential equilibria exhibit different comparative statics. So we are going to introduce a novel equilibrium refinement, which we will call belief stability. Why a novel equilibrium refinement? There are so many equilibrium refinements out there. Well, as I said, we have multiple sequential equilibria. These things are quite robust already to the standard repertoire of equilibrium refinements. So we're going to take a slightly different tack and think about perturbations to beliefs rather than various other things we might do accepted in the literature. So I know you don't come to a polycon talk, an applied political economy talk, expecting to see a new belief refinement introduced, but the comparative statics drive us to it. That's my excuse, and I'm sticking to it. And finally, I want to point out that we're going to have a very robust prediction, and I mean robust in a series of different ways that I hope I will get a chance to at least touch on in this talk. We have a robust prediction that more ex-ante preference divergence yields more information disclosure, which is absolutely contrary to the cheap talk results that are, more the bread and butter of the literature on advice to policymakers. So I want to think about that and highlight that for you now, just in case anybody else has to leave early too. So let's see, I already highlighted how our results are going to be very different from those in the literature on disclosure games and how they will be different from applied work that uses a cheap talk technology. So let me just zero in on the second one. There are other works out there that get partial disclosure in games of verifiable advice. I just want to point out the last one there, Denisenko, Hafer, and Landa in the AJPS. So that's our other paper, our first foray into this topic. It's a related model, but importantly different in a variety of ways I won't go into. But one thing I want to highlight about that is that in that paper, you need to have an explicit reward for disclosing the state in order to get the agency to disclose at all. So this is going to, in the paper that I'm going to present today, they have entirely different motivations for disclosing. So that paper is doing other things.
Can I ask just a clarifying question about this literature? So you're not doing cheap talk, you're doing this disclosure.
Yes.
But this is nothing to do with sort of communication with commitment and flexible information design. That's not this.
No.
Just the,
no.
Okay.
So this is not. We're not designing an experiment. Okay. So in the talk today, I'm going to spend most of our time talking about a special case where we have a uniform prior, quadratic loss preferences, and a state-independent sender preferences. I will introduce to you the structure of the game, characterize equilibria, which we can do very neatly in closed form in this case, and we can talk about the effects of preference divergence and these comparative statics that we get out of different equilibria, and introduce the belief stability equilibrium refinement. And then I'm going to, relatively speaking, breeze through. We're able to get from this simplified model. We're actually able to see better in a lot of ways, sort of what's driving the results. So I want to try to lay those mechanisms bare with that simplified model. But we do have a more general model in the paper, so I'll briefly talk about that and about, equilibrium and comparative statics there. And then I'm also going to briefly talk about some robustness checks we do where we, vary somewhat the strategy space for the sender. So hopefully
can I ask
touch on that too. Yes.
myself some clarification? Because at the beginning you said, oh no, one of the things that the standard literature on disclosure games assumes is state-independent sender preferences. We're going to do something different. And now you're telling me you're using state-independent sender preferences.
So, well, in the general model, we allow state dependence. So let me put that in there. But the thing that I think bears more emphasis here is not that they're state independent, but that they're non-monotonic. So while it's true that for my simplified model here that I'm going to first lay out, we're going to have state independent preferences for the sender, they're going to have an ideal point that's in the interior of the state space.
Okay.
So unlike in the standard, like the Milgram 1981 paper, where, they have information to reveal to the receiver about the quality of the car, but ultimately what the sender wants to do is always just sell more cars.
Okay,
right?
So the essential property is non-monotonicity, not state independence. Okay.
Yes, that's correct. It's as our title says, I believe our title is non-monotonic disclosure. So yes, it's an equilibrium result, but also assumption on the nature of preferences.
Okay.
Okay. Anything else before what other confusions have I created before even showing you the model? Okay. Thank you for diving right in. So we're going to have two players, an agency and a policymaker. Nature is going to determine a realization of the state of the world. For now, I'm going to suppose that the states of the world are just uniformly distributed on the interval -1 to 1, so with mean 0. Then the agency is just going to observe the state directly, so we have no fancy signaling technology in here. They will just go ahead and observe the state. And then they're going to choose a message to send to the policymaker. And so, and again, we will extend this later, but we're going to think for now about, they can either just reveal the state, which they have observed directly, or they can not disclose the state, right? Because we're not going to allow them to lie. In the robustness section, we can talk about things like, partial verifiability and vague messages and so on. But for now, we're just going to keep this extremely simple. So the policymaker then observes that message, right? Either the disclosed state omega or the fact that the agency chose not to disclose. And then they're going to choose a policy. All right. Okay. So we're going to suppose that the agency and the policymaker both have standard quadratic loss preferences. So the agency is happiest when the policymaker chooses a policy P that is equal to her ideal point I. The agency's ideal point I, excuse me. The policymaker, on the other hand, wants to choose a policy that equals the state. So we can think of the absolute value I as a measure of the ex-ante actor's preference divergence. All right, I'm jumping ahead, I guess, with sequential equilibrium, but we're gonna characterize equilibria and we're going to characterize sequential equilibria. Okay, so that's our equilibrium concept here, is sequential equilibrium. So in every equilibrium, the policymaker, if she knows what the state is, if that information has been disclosed to her, she's going to choose a policy that's equal to that state. If, on the other hand, does not observe the state, the agency chooses not to disclose the state to her, then she's going to understand that, okay, the state must be, in the set of states for which the agency chooses not to disclose the state. So my best choice of policy is going to be the expected value of the state, given that the state was not disclosed to me, right? So I'm going to call that X star. So X star here is always going to be the policy chosen absent disclosure. The agency, on the other hand, is going to choose to disclose the state whenever the state, which is to say policy equal to the state, would be closer to our ideal point than X star would be. And if it's going to be farther away from her ideal point than X star, then she will prefer not to disclose and take policy X star. So of course, we have a finite support here for the state space. So we may run into those boundaries. So she's going to always disclose. I'm just going to think about the ideal point of the agency as being positive, greater than the mean of the distribution of states. So if that's the case, then she's going to disclose the state. If the state is greater than X star, but less than her ideal point, plus the interval I minus X star.
So, Katie, can I ask a question?
Yes.
At some point, have you made an assumption that ensures that there is no can there be full disclosure?
There can be full disclosure, of course. The agency can choose to disclose all states.
But then, so in this like left, so policymaker column that you have, are you making an assumption about the out of equilibrium beliefs?
We will.
Okay.
And that, but subject to, and we are going to only look at sequential equilibria here.
Okay.
So,
okay. Thank you.
So that will discipline us.
Mm-hmm.
Right? But yes, basically, if I is positive and there's full disclosure, then X star would be -1. Okay. So let's think about our equilibrium disclosure strategies. This is kind of the interesting thing going on. In equilibrium, in our simple game, there can be a maximum of 3 disclosure strategies supported in equilibrium. One of them is full disclosure, as you just asked. So the agency could be disclosing all states between -1 and 1. There could be partial disclosure, and there are actually 2 partial disclosure equilibria we're going to look at here, a more expansive one and a less expansive one. So in the more expansive equilibrium here, so this is for I positive, as you can see on the graph, the figure I is greater than 0. So we have under the blue bracket, the area that the set of states that would be disclosed by the agency, and the hatched area to the left and to the right indicates areas she would not disclose. So one important thing here is if you have partial disclosure, there must be states on both ends that are not being disclosed, right? Because your policy absent disclosure, right, can't be driven to too great an extreme. So let me go back here. Okay, here we are. So we have 2 different partial disclosure equilibria here that are possible. One is more expansive, one is less expansive. I'm going to refer to them as M and L accordingly. So you can see that the less expansive disclosure strategy is completely nested. That disclosure interval is completely nested within the disclosure interval for the more expansive strategy, which is to say in the more expansive equilibrium, they disclose more high states as well as more low states than they would in the less expansive equilibrium, right? And correspondingly, we can identify the policies absent disclosure, and they order very nicely, right? So in full disclosure, it's going to be driven to -1 for I greater than 0. The more expansive equilibrium is going to yield a policy absent disclosure that's somewhat higher. The less expansive equilibrium, a policy absent disclosure that's higher than that, but all of them for I positive are going to be less than the mean value of the distribution of states 0.
Can I ask
Yes.
just so are you saying that there's only these 3 precise intervals, which is the whole -1, 1, XM star, and I suppose the equivalent value?
For our
or are
simple
we saying that there's everything in between full disclosure and the red one? I mean, it depends on the.
No. 3 distinct equilibria at most.
Okay.
In our simple game where we have our quadratic loss functions and uniform distribution
Right.
-1, right? So there are at most 3 equilibria in this game.
Okay.
And in particular, if we think about jumping ahead, so I jumped right over my roadmap, so I'm on to effects of preference divergence. So here we have I on our line here, and I've drawn in -1 and 1, which are the boundaries of the state space. If I is between -1/4 and 1/4, in other words, if the ex ante preference divergence between the agency and the policymaker is not too great, then we can have all 3 of these equilibria: the full disclosure equilibrium, the less expansive partial disclosure equilibrium, and the more expansive partial disclosure equilibrium for that interval. If I is more extreme, either greater than 1/4 or less than -1/4, or greater than 1. It could be less than -1. But the situation becomes more like Milgram 1981 and uninteresting for us here, right? Then the only equilibrium that's allowed is full disclosure. So you could kind of think of this as mirroring, in sense, the Milgram 1981 result or the Grossman result, right? If I is greater than or equal to 1 or less than or equal to -1, essentially we're saying here that for all states, they will always want something higher, right? So just to fill in that little piece.
So the kind of weird thing about this is that the set of possible equilibria is not convex. In other words, you have these 3 distinct equilibria, but a convex combination of the last 2, for example, doesn't work.
No, it
So
doesn't.
that's where I guess that's okay, fine.
I didn't anticipate this question at this point in the talk, or this question at all. But later in the talk, when we talk about belief stability, I'm going to be able to put up a figure that's probably going to help make that somewhat clear.
So, Katie,
Okay. Yes.
are these equilibria Pareto ranked, or?
Well, they're not Pareto ranked because they can be ranked by welfare, but the agency and the policymaker, the policymaker prefers more disclosure to less disclosure.
Sure. Yeah.
Right. So full is best for them, then more expansive, then less expansive. For the agency, it's the other way around.
I see. Okay.
Sorry, one last my question.
Yes.
Did you make any a priori assumptions, like, for example, only pure strategy equilibria, or is it obvious that only pure strategy equilibria exist?
We didn't make any assumption. We only have pure strategy equilibrium.
Okay.
And again, that's something that might be more apparent later when I will put up a graph that shows that graphs expected value of omega given non-disclosure against x, right? Where we let x be a parameter in that case, dictating that parameterizes that disclosure interval. So where is that disclosure interval? Somewhere here I had it. Right, so the disclosure interval you could think of for I positive as being from x to 2i minus x, right? So if you treat x, okay. Let me come back to this when we get to the picture. Sorry. All right, where are we? Here. All right, so so the effect of preference divergence on equilibrium disclosure. So again, let's just think about the ideal point of the agency being greater than the mean of the distribution. So in our case, I greater than or equal to 0. So preference divergence I, our ex-ante measure of preference divergence I, is going to have both direct and indirect effects on disclosure. You can see it has a direct effect on disclosure in red here because we have I directly in the upper bound of our disclosure interval. It also has an indirect effect on disclosure because X star, which I've put in blue here, is also a function of I. So we'll have the direct and the indirect effects. The direct effect always weakly expands the disclosure interval. As you can see, the direct effect here, the upper bound of the disclosure interval is increasing because it's just pinned down by 2i minus x. So if we increase I, that's of course going to increase as well, so expanding our disclosure interval. The indirect effect, however, through X star is going to depend on whether we're in the less expansive equilibrium or the more expansive equilibrium. So the indirect effect is going to improve communication in the less expansive equilibrium, which is to say I decreases, but it's going to reduce communication in the more expansive equilibrium, which is to say X will increase, right? Pulling in both the lower bound and the upper bound of the disclosure interval. So let's look for just a moment at a graph of the more expansive equilibrium here. So this figure gives us on the x-axis the agency's ideal point I. On the y-axis is the state omega. So just looking here, the red line, the red dashed dotted line in the middle is the agency's most preferred policy. So that's just I as a function of I here. To let us see that this blue area, the blue area is the disclosure interval, the set of states that's actually disclosed in this more expansive equilibrium by the agency. We can see that that's centered around the agency's preferences, the red line. And you can see that it's increasing as I goes to 0. and decreasing as you go away from it. It's bounded here at -1/4 and +1/4 because at that point, it's no longer possible to support the partial disclosure equilibria when I is too far away from 0. So here the communication between actors is going to deteriorate as I increases in the more expansive equilibrium. Here we have the same kind of figure. I've left the dashed blue lines in for the more expansive equilibrium, but now the solid orange lines and the orange shading are showing you the disclosure interval in the less expansive equilibrium. And you can see you've got the opposite comparative static. Here, that disclosure interval is collapsing as I goes to 0. So communication between actors here is going to improve as I increases, as the magnitude of I increases, as the agency and the policymakers' preferences, ex-ante preferences diverge by I departing from 0, you're going to get more communication between the actors in the less expansive partial disclosure equilibrium. Okay. And of course, it's not affected by I in the full disclosure equilibrium. We have a full disclosure equilibrium here for all values of I, as you may remember.
So, Kafi, just to understand the figure,
Yes.
the less expansive equilibrium, if they have the same ex-ante preferences, is actually the one that's a bit less intuitive, and that's
Right.
but it works because you don't care about the state. You want action 0 in that case, right?
Exactly. So if
So-
I were equal to 0, so their ideal point is the mean of the distribution of states, right? Then they are best off simply not disclosing the state, or alternatively disclosing the state when the state is exactly equal to 0 and not disclosing it otherwise, which is effectively the same thing. So that's a non-disclosure equilibrium that will exist for us here if I equals 0.
Okay.
And that's a situation that's going to maximize the possible welfare of the agency and minimize the welfare in expectation.
So can I ask a question here?
Under
Because
C.
the most expensive equilibrium also works because you're giving them, again, it's a uniform distribution, so you're reporting nothing. And so let's say with I equal to 0, okay?
What do you mean? Sure.
No. So in the more expansive equilibrium, no, you are reporting everything, right? So you're reporting all the
Yes.
states.
So thank you. In the more expansive equilibrium, if I equals 0, then the more expansive equilibrium is going to be a full disclosure equilibrium. They'll reveal everything.
And ex-ante, that's okay, because off equilibrium path beliefs, if you don't report, are going to be very unfavorable. So anything is going to be inside. Right. That's how it works, right?
Right. So if I is positive, then the off path of play beliefs will dictate a choice of policy equal to -1.
So the reason there are more equilibria that are somewhat in between is because you here essentially not reporting is the only thing you can do off equilibrium. So basically you are playing with beliefs a lot. Off equilibrium path beliefs are essential here in the sense that anything in between would not be sustainable by any off equilibrium path beliefs that you would have. You'd have things that are on, you'll always have too many things that are on the equilibrium path, and that would destroy everything. Here you're basically
I will show you this figure because I think this will help, but you have to ignore many things in this figure because I didn't design it to answer this question. So there's a lot of extra stuff going on. But here, so on the horizontal axis, we have a parameterized version of the policy choice if in the case of non-disclosure. So let's just suppose that, anytime the agency does not reveal the state, the policymaker will choose policy X. That's on our x-axis. The blue dashed line then is just, y equal to x, the 45-degree line. And on the y-axis, we have expected value of omega, given that omega was not disclosed, where we're going to assume that they will disclose omega. The agency will disclose omega if omega is between x and 2i minus x. So again, this is for I positive, right? So you can think of that as a summary statistic for beliefs, right? The policymaker's beliefs after non-disclosure. So the orange line here is our summary statistic of policymakers' beliefs after non-disclosure. So you could think about how that travels as a function of this parameterized x. Now, of course, in equilibrium, x has to actually equal the expected value of omega given non-disclosure, right? So our equilibria are going to be where the orange function here crosses the 45-degree line. It will be where the orange and the blue dashed line intersect. So that's why we have potentially a full disclosure equilibrium, a more expansive partial disclosure equilibrium, and a less expansive partial disclosure equilibrium. Obviously, this graph was drawn for I less than 1/4. I equal to 1/5, that says at the top. Okay, so this is why you can't just dictate any disclosure interval and support that in equilibrium, in a sequential equilibrium. Okay, does this help? So backing up a bit here, where are we? Okay, so here comes the equilibrium refinement, right? So what do we have so far? We have, for sufficiently small I, multiple equilibria that give us contrary comparative statics on the very important question of how much is communicated in equilibrium as a function of the ex-ante preference divergence between the agency and the policymaker. All of these equilibria are sequential equilibria. They all survive standard equilibrium refinements. But we'd like to kind of figure out, given these contrary comparative statics, are some of these, more robust in some sense, more reasonable to believe than others. So let's think about our equilibrium refinement this way. Our equilibrium refinement is going to consider the possibility that the receiver may have somewhat incorrect beliefs, right? So think of it this way. We have an equilibrium. We have a strategy profile sigma and a system of beliefs mu in that sequential equilibrium. Suppose that the policymaker's beliefs are just a little bit wrong. So imagine that we have some perturbation of the policymaker's beliefs. We'll call it mu epsilon, or mu epsilon sub j, I guess, for player j here. So let's consider that perturbation of beliefs, and then let's build a strategy profile that will be sequentially rational given those beliefs. So in particular, build a policymaker's best response policy choice given those that's optimal given those perturbed beliefs. And then let's think about the agency. Suppose the agency understands the policymaker's response function and best responds to that in their choice of what states to disclose. So that's going to define our sigma epsilon here, which is the strategy profile, which is sequentially rational given the perturbed system of beliefs. And then let's take that strategy profile and build from it the beliefs that the receiver, the policymaker, ought to have to be consistent, Bayesian consistent with sigma epsilon. So essentially, it's like what we're saying is here, suppose their beliefs for some reason are wrong, but everybody optimizes behavior with respect to those beliefs, with respect to the policymaker's policy choice strategy. And then let's say, okay, suppose the receiver is in the world where that strategy profile is being played. What kinds of beliefs should they develop based on that strategy profile and Bayes' rule? Okay, so now we have all our elements. Here's the condition. If there exists a neighborhood around the policymaker's beliefs, such that perturbations of their beliefs within that neighborhood will lead via sequentially rational behavior and updating based on that behavior back toward the original mu, then we're going to say that the equilibrium is belief stable. If, on the other hand, it's going to cause them to update to new beliefs farther and farther away from the original belief system for our original sequential equilibrium, then we're going to say that equilibrium is not belief stable. And we can think about how large an epsilon can we have that's going to satisfy this condition for belief stability. We can think of that epsilon as a measure of the extent of belief stability where it's stable. So looking over here at our graph on the right-hand side, as I said, The x-axis is just going to be a parameterized policy absent disclosure, and the y-axis is going to be this summary statistic for belief, expected value of the state given non-disclosure, where disclosure is understood to be, they understood to be disclosing states between x and 2i minus x, right? So we look at this orange line, that's mapping out that expected omega that's representing our beliefs here, our summary statistic for beliefs. So suppose we start at, I forget which one I'm starting at. Let me see which one I'm starting at. More expansive equilibrium. So look at the more expansive equilibrium that's marked with the M there. So if we suppose that beliefs are just a little bit different, right? So go somewhere on that orange line, just a little bit away from the blue dot at the intersection of the blue and orange lines there. And then you say, okay, well, what would be optimal policy choice, right, if they have those beliefs, and what would be optimal disclosure then parameterized by X, right, given those policy choices? And then how do you update beliefs based on those strategies? Basically, they keep moving, the little arrows are moving farther and farther away, bouncing between our orange line and our blue line, farther and farther away from M. So M here, the more expansive equilibrium, is not belief stable. On the other hand, if you look at L, our less expansive equilibrium, and do the same kind of exercise, our little red arrows here are bouncing between the blue line and the orange line back toward that orange point that indicates the intersection between the two, the less expansive equilibrium. The less expansive equilibrium is belief stable in this case, as is the full disclosure equilibrium that we have in this graph. Okay, so what's the corollary, the takeaway from this result? If the equilibrium is belief stable, that means that communication is going to improve as preferences diverge, right? Ex-ante preferences, the difference in ex-ante preferences diverge. If the equilibrium is not belief stable, then communication worsens in preference divergence. So what's our takeaway here? Our takeaway is that we should regard the belief stable equilibria as the more robust predictions. And so we should expect that communication is going to improve in preference divergence, right, rather than worsen.
So can I ask a question about the solution concept itself?
Sure.
Is it in some sense related, because this is stability, and the stability of Nash equilibria, just these standard, single shot games, is also, like in Cournot equilibrium, it's also based on the same thing or similar concept. Then you perturb the equilibrium in the neighborhood, and if the best response functions have a particular slope, then you diverge. In some cases, you converge. Is this a generalization, or is it?
Well, we're
similar?
attacking beliefs, right? And you're talking about a solution concept that's used in complete information games. So,
But you can present
I mean, not only
a Nash equilibrium also as a belief, so people best respond to beliefs about what other people are going to play.
conjectures. Yeah.
Conjectures.
Um,
It seems to me, okay, maybe a different question is it does this thing exist, this refinement in the literature?
It does not seem to exist in the literature, as far as we can tell. So attacking the point of weakness here of what are the receiver's beliefs seems to be something that has not been done. All the elements of this are very familiar, right? We were not seeking to do something radical. We were seeking to do something that would be conventional, right? Subject to the unhappy realization that the equilibrium refinement we needed didn't seem to already exist in the literature. Otherwise, we would have used that.
But maybe
if you know something out there that looks like this, I would love to hear about it.
No, my point is that if there exists, for example, a formal stability concept for standard static Nash equilibria, then there's a natural question: what is the extension of that to a Bayesian game? Right? So best response stability. That's it.
Yes. Okay. All right. I still have a general model and some robustness to talk about, and I think I only have between 5 and 10 minutes. So let me try to be judicious. So let me outline. I don't want to get into all the gory details of what we do. There is a paper, which I will make sure to share. So immediately I'm going to go to class, but after I come back from class, I'll be sure to share that link with you. I apologize that it wasn't already out there. But it's in the paper. So instead, I'm going to try to give you a general tour and hope it's not too bewildering. So basically, the way we go about this is first, and this becomes, I will rationalize this approach. Okay, first let me talk about the general model. What is it we generalize? So let's think about any continuous cumulative distribution function f on a compact and convex support. We're still going to suppose that the agency just directly observes omega. We can put in signaling technology there. It just creates a mess and does nothing for us. So we're leaving the agency observes the state directly. And for now, we're also going to assume that the agency just either reveals that state or does not. And in the robustness check, we think about, is anything really going to change if we have partially verifiable messages or if we have vague messages and that stuff. But here, again, they just either decide to disclose the state that they've observed or they don't. And then the policymaker is going to observe the message and choose policy. So we're generalizing their utility functions here. We're generalizing the form of the utility functions, but we're going to retain these unique ideal points. They retain the unique desire to match the state perfectly for the policymaker. For the agency, we're going to generalize this a bit and suppose that they could have state-dependent preferences too. So we're going to let their ideal point be some weighted average between the I that was previously their ideal point, and why I keep referring to their ideal point as a measure of ex-ante preference divergence. It was just a measure of preference. Well, okay. I is this additive preference component, and then we'll have the weight alpha is going to be the other parameter of their ideal point. So they put weight alpha on matching the state, weight 1 minus alpha on achieving some ideal point I, which might be something like a status quo, might be some policy that's cheap and easy for them to implement, might be something about their ideological tastes. We're neutral on that, but can think of telling many stories. Then we're going to have a series of propositions addressing full disclosure equilibrium, non-disclosure equilibrium, partial disclosure equilibria. Basically, our full disclosure equilibrium proposition gives us necessary and sufficient conditions for belief stability given the existence of a full disclosure equilibrium. It also gives us a sufficient condition for non-existence of full disclosure and a sufficient condition, thanks to Seidman and Winter, for existence of a full disclosure equilibrium. That might seem unsatisfying, but hang in there. You have to see the collection. You have to see the entire picture before you can be dissatisfied. So the second proposition is for non-disclosure equilibria. That's going to give us a necessary and sufficient condition for the existence of non-disclosure equilibria. And it demonstrates that non-disclosure equilibria, when they exist, are always belief stable. And third, we have a result for partial disclosure equilibria that gives us a necessary and sufficient condition for the existence of partial disclosure equilibria, but doesn't tell us anything about their belief stability. However, and this is the fun part, finally we get to the fun part, right? There's a nice pattern to our equilibria where we have multiple equilibria, right? The disclosure intervals are still nested, right? They are completely contained one within the other. So the equilibria can be ordered. They can be ordered by the disclosure intervals. They can be ordered by either agency or policymakers' welfare. They can be ordered by policy in the absence of disclosure, whatever you like. The important thing is they can be ordered, and belief stability of the equilibria is going to alternate on this order. So once we have this ordering, right, if we determine the belief stability of any one equilibrium, that's sufficient to determine the belief stability of all the equilibria that we have, right? So the fact that we know necessary and sufficient conditions for when we have full disclosure, and that full disclosure equilibrium, and we have a test for when a full disclosure equilibrium, a necessary and sufficient condition for when a full disclosure equilibrium is belief stable. The fact that we know we have necessary and sufficient conditions for the existence of non-disclosure equilibria and know that it is always belief stable when it exists. This is going to allow us to pin down belief stability for all of our equilibria.
So here you have more than two non-full disclosure. In fact, I guess they're finite, I suppose, or something like that.
More than two, I'm sorry, more than two what?
In general, you can have more than two equilibria when
Yes.
you don't have a uniform and so on. They're finite, and basically the least disclosure one is going to be does this mean that the least disclosure one is always going to be belief stable, the next one is the disclosure less is not, and then the one after that is again belief
It
stable?
does not necessarily mean that, but for a lot of the environments that are standard in our applications, yes,
Right.
that will be the case. So yes, that's the natural intuition. It's actually more involved, but that's the natural intuition because most of the environments that we work with, that will be true.
Okay.
Most, I mean, I don't know, these are a little bit dangerous statements here. Maybe now I have to worry about that recording going up on YouTube.
So, Katie, can you remind me what does non-monotonicity mean in this general model? Is it just omega can go below or above I, or is it something else?
No, it means that sometimes the agency would like the agency, so they, sorry, the agency's preferences over the policymaker's actions are non-monotonic, right? So for, very low actions, they'd like them to choose a higher action. For higher actions, they'd like them to choose a lower action, right? So you have
Yeah, okay.
that's all, right? But this is in contrast. So this is very standard in our spatial environment, but it is not the assumption that's typically made in disclosure games.
Thank you.
All right, let's see. What do I have left? So what are the big takeaways here on the comparative statics? So comparative statics are shared by belief stable equilibria. There's a little bit of a twist in that some of the comparative statics will flip depending on whether the policy that's chosen in the absence of disclosure is greater than or less than I, right? So in the paper, we spend some time then trying to characterize the conditions that will generate those different situations. But the part that I'd like you to, and we have a remark that basically says, well, the case that generates the comparative statics that I've been emphasizing to you, right? That more preference divergence leads to more communication in equilibrium. That actually encompasses a lot of the standard environments in our applied work. So when is X star going to be less than 1 and generate these comparative statics that I've shown you that are perhaps so contrary to what we'd expect from cheap talk? It's when we have distance-based utilities. Alpha, the weight on the state for the agency, is not too large. And the tails of the prior density are not too asymmetric. One of them is not too much fatter than the other. That actually, those conditions are actually satisfied by a lot of our standard environments. So far, what I'm telling you is, you should take seriously the possibility that if you're dealing with a situation where information is verifiable, you should be looking at a situation where you could well be looking at a situation where greater preference divergence between the advisor and the policymaker is actually going to lead to more information revelation in equilibrium. Let's think about some other ways we might undermine these findings. So what if messages are partially verifiable? Suppose we allow them to observe with probability Q that the message is true, and with probability 1 minus Q, they're not able to verify it. They don't know whether the message was true or not. We're still going to retain an equilibrium with partial disclosure, and it's still going to be the case that is belief stable, and it is still going to be the case that disclosure increases in the ex-ante preference divergence in that equilibrium. Suppose instead we allow vague messages. So suppose I have to tell the truth, but the truth can be vague in the sense that I'm going to tell you that, basically make a statement to the effect omega is a member of some subset of the state space, right? You're still going to retain, we're able to basically reconstitute our less expansive partial disclosure equilibrium in that case. So like thinking about the environment of our simple model at the start. We can recreate our less expansive partial disclosure equilibrium. It's going to have the same effective disclosure interval, the same effective policy choices. And once again, then the same comparative statics, the disclosure in equilibrium will increase in the ex-ante preference divergence between the agency and the policymaker. Okay, incredibly, I think I made my time limit. Oh, but I missed it by 1 minute, maybe. All right, so the big takeaways. In a model with verifiable communication between a policymaker and an informed bureaucratic agency, informed advisor, when the agency and the policymaker's ex-ante preferences are sufficiently aligned, unraveling may stop before it's complete. So there may be only partial disclosure in equilibrium. Greater ex-ante preference divergence can encourage the agency to disclose more information rather than less, and that's true both in the sense of within the belief stable partial disclosure equilibria, they will disclose more as I increases, and also in the sense that as I becomes very large, you'll actually have a unique equilibrium, which is full disclosure. And finally, equilibria, well, I just said the same thing again. Equilibria where communication improves with preference divergence are belief stable. We should regard those as being the equilibria that are more robust, right? And the prediction, the comparative static prediction that we think we should expect to see then. Thank you.
Okay. Thank you, Kathy. Do you need to go now?
Well, you know, I'm willing to be a couple minutes late.
Okay.
Advantages of tenure.
I mean, no,
I can
I
take
asked
one or two
because
questions.
I noticed that both Anna and Dimitri are here, so maybe
Okay.
we can have a discussion with them if you have to go. But you know, you're a speaker, so if as long as you can stay, stay, please. Right. I wanted to say something after the recording is over, so I'll say that later. But does anybody have any questions? And just unmute yourselves if you do, please.
Don't have any questions, but this picture, when you have the stability, these little arrows, that is very suggestive. Just want to, you know, because when Francesco said there's finitely many equilibria, this suggests that actually there could be, you know, odd number of equilibria generically, because obviously you can have a little tangency between one of those dots not crossing. So that would be but other than this, that would mean, and that reminds me, I think, you know, in some areas, this is called index theorem, where this thing switches from one angle to another, and it reminds me all the sort of coordination games with complementarities, but that might not be the case here. But anyway, that was just a comment where I would sort of look for inspiration.
Thank you.
Okay. Anybody else? I might even have had things to say which can be said during the recording, but anybody? Okay, then I'll go. So what is interesting here is that I would have guessed that so there is this idea that first of all, you cannot have a continuum of equilibria. Essentially, you have this, you know, in the uniform you only have 3, but then in general you have finite and so on. And I suspect, can you still give me some intuition as to why, if I have an equilibrium, say the least disclosure one, then one where I disclose just epsilon on both sides a little bit, that cannot be sustained?
So if I understand you correctly, I think the figure
Take
that
this
comes
L
between-
thing that you have here in this figure, that corresponds to a certain interval that's being disclosed, right? From
Right.
a negative to a negative thing. Okay, so now
from X
enlarge,
to 2i minus X has been disclosed.
yeah, exactly. Now enlarge it by, I guess, epsilon 1, epsilon 2, or just a common epsilon.
Right.
Why isn't that an equilibrium? Not even,
So
and let's forget about belief stability, because you're claiming this is not even a sequential equilibrium, right?
It is a sequential equilibrium.
No.
All
I'm
of them
saying
are.
I'm saying if you enlarge by even
Oh, I
just
see.
epsilon, the new interval cannot be sustained in a sequential equilibrium.
Well, so if we enlarge the disclosure interval a bit, then we're changing the expected value of omega given non-disclosure a bit. So we're moving on this orange line, right? As we change our disclosure interval, we're moving off this on this orange line a little bit off the blue dashed line, off that point of intersection, right? And so because at the less expansive equilibrium, our little red arrows are pointing us back toward it, it's basically saying that as
Okay,
the
can I-
policymaker adjusts to that, yes.
Can I? So here's what I don't understand. Suppose that I is equal to 0, right? So I am, as a sender, I'm not obviously going to want to go either left or right. So I'm just going to make it a little bit, I'm going to disclose a little bit more, I suppose, or I could even move it inside a little bit less. Why would that expectation of omega conditional necessarily move? That's what I don't understand. Can I not make a change? In other words, can I not use this epsilon to leave it exactly where it is? That's got to be the key. That's what I don't understand.
So you want to make an asymmetric expansion of that interval, right?
Well, I don't know. Maybe I need to. I don't know.
I
That's
think,
what I'm
yeah. So if you're going to leave it unchanged, I think you need to expand differently on each side, right? But then one of those is going to be unfavorable for the sender, right? The sender is going to prefer non-disclosure to one of those, right? So it's just not sequentially rational for them.
I guess I don't understand why it needs to be asymmetric if I is equal to 0, but I don't know.
Oh, I see. I missed the I equal to 0 condition.
Yeah. Kathy, I'm gonna let you go because I'm kind of worried that I'm making you miss your class. But
I am. Anna, are you there?
Yes, I'm here. I can answer this question.
Okay,
now,
great.
So you can run.
Anna, thank
Okay.
you.
Absolutely.
Is there a way
So
for me
let's-
to give you control over my slides, or is that too?
There is no, but I have slides on hand, so if need be, I can just
Okay.
build my own.
Okay.
And I will leave this on, but I will depart. Thank you very much, everyone. Thank you for the
Thank you, Kathy.
questions.
Thank you.
Okay, so imagine that I is equal to 0 and you're expanding symmetrically around your ideal point, your disclosure interval. Then
Yeah.
absent disclosure, what is the optimal policy? It actually will be just 0, right? Because you're expanding
Right.
symmetrically, the expectation given non-disclosure still remains symmetrically 0. But
Okay.
then what would be the best response of the agency? The best response of the agency would just be not to disclose inside this small epsilon neighborhood of 0. It would be just to disclose at 0. So it eventually will, as if, collapse into itself, reproducing the stability argument.
Okay, Anna, I have to admit I probably need to read the paper. I'm wasting everybody's time too much.
No,
on this.
I think this is, so my understanding is that take a random sort of minus x plus x interval. Think about the incentives of the guy, it's like x minus epsilon. He really wants to reveal, right? Because like if he doesn't reveal, the receiver is gonna take 0. You are x minus epsilon, you want to reveal.
No, but here's what I don't understand. If you're I equal to 0, you want the action to be 0 all the time, right? That's
I
the
see.
point.
Okay, yeah, you're right. Okay, so
Exactly.
then,
You want the action to be 0. Imagine that there is a perturbation to the policymaker's belief that make him, for some reason, instead of selecting 0, selecting something else, selecting minus epsilon.
But Anna, you're using belief stability now, right? You're
Okay,
not using.
right.
Are you using
Let's go.
sequential equilibrium?
Right. Let's go back and forget about belief stability. So imagine that there is an equilibrium such that the agencies is disclosing in the interval minus epsilon to epsilon. Imagine that that is an equilibrium. Absent disclosure, the optimal policy selected by the policymaker will be 0.
Yes.
Because the disclosure interval now is symmetric around 0. Non-disclosure is symmetric around 0. You're just collapsing into 0.
Agreed.
But then what is the best response of the agency? Agency knows that if it were to disclose something, this is the policy that the agency would receive. But if it were not to disclose anything, it would instead receive 0. Because this is the policy absent disclosure. So for the agency that observes, let's say, epsilon divided by 2, disclosing epsilon divided by 2 is less preferred than just keeping it
Okay, so
silent
that makes
and
sense.
receiving 0.
Okay, so that makes sense. Fine. Okay, good. But then now I'm asking, why are there numbers? So there is an epsilon for which this argument doesn't apply, right? So because
There is
we have this disclosure equilibrium, we have this L equilibrium.
Correct. But we only have this L equilibrium, which is different from non-disclosure when I is positive.
Ah,
So when
that's
I
right.
is
That's
equal to
right.
0,
Because no, that's right. That's right. That's right. Okay, I think I am beginning to see. Okay, that's right. Because if then yes, the two lines were crossing. Okay, okay,
And
good. Sorry
Francesco,
everyone for hogging this.
we can stay longer. Francesco, you have to change your shoes again to being the host and
Yes.
finish the recording, and then we can stay.
I just wanted to thank Anna, Kathy, and Dimitri, who's in the background, for attending this, especially Kathy for presenting. I'm gonna stop the recording.